Question 2, we have a Jeep of mass 2375 kilos pulling a trailer of mass 350, and we have our angle theta here. They move at a constant speed, so there's no acceleration here, so the forces must be equal, opposing forces. The engine exerts a force. We have the force up the hill, 4400 newtons, and the forces due to friction are 1525 and 375. That's the Jeep and the trailer. We're asked to draw a diagram showing the forces on the Jeep. What's happening with the Jeep? We have an angle theta. Let's say our Jeep is here. We have our reaction going in this direction. We have theta inside. We have mg. We have mg sine theta. And we have mg cos theta. And we have the mass of the Jeep 2375 g cos theta, and this is going to be 2375 g sine theta. We also have the force up the hill, 4400 newtons. We also have a resistance force. It's a combined resistance force here. 1525 plus 375 is 1900. So 1900 newtons are resisting, going in this direction. There is another force at play as well, so just be careful. If we take the trailer of mass 350, we're going to have 350g. We're going to have 350g cos theta, and parallel to the slope we're going to have 350g sine theta. So that's another force that will be going down, affecting the Jeep in this way. 350g sine theta. So that's, I think that is everything. So we have, well, we got 3 forces going down in this direction. 1, 2, and the third black one. So with no acceleration, they have to be equal to the 4440 in the other direction. So we can say 350 g sine theta plus 2375 g sine theta. We also have the 1900 has to be equal to the 4400 opposing it. So that is going to be 2725 g sine theta equals, that will be 2500. So if we divide 2500 by 2725 g, that will leave sine theta over here. So to get theta, we just get the inverse sine of the right hand side. 2725g, and this is giving me an answer of 5.3716 degrees. Is there rounding? Doesn't ask for rounding. 5.37 degrees, or 5.4, or 5 degrees, whatever they really want here. They haven't asked, so I'd leave it as 5.37. Part 2 of question 2, we have a student and a pulley experiment or arrangement. So we have 2 weights, they're given in terms of newtons. So mg for the first one, mg is going to be 24.5. So the mass of this one is 24.5 over 9.8. So the mass of that one is 2.5. And the other one, 44.1 divided by 9.8 is equal to 4.5 kilograms. We will need those. So let's look at the weights first. We have two strings in the middle, so we have our acceleration A and B. So we have this in terms of newtons already. We have 24.5 for its weight. We have tension in the string. This is W1. Let's look at W2. Also has tension in a string. It has 44.1, and with the masses of 2.5 and 4.5 means this is going to go down in this direction, so the weights will be going up. So this one with an acceleration of A and this one with an acceleration of B. My 6.3 kilos is given to me in terms of kilos. I have two strings, so I'm going to have 6.3 G, and I'm going to have the average of the accelerations, A plus B over 2 will be the acceleration going downwards. So I think that's enough. We're asked to solve for T with part 2 here. They're the forces. So we have T minus 24.5 is equal to, we got 2.5A. For the second one, we're going to have T minus 44.1 is equal to 4.5B. And for the 6.3, we're going to have 6.3G minus 2T is equal to M 6.3 times the acceleration A plus B over 2. So maybe the best way to do this is to get A plus B. 6.3 minus 2T will be equal to 3.15 times A plus B. 3.15 divides into 6.3. It doesn't divide into minus 2T, so I just might leave it like this for a second. So what's A equal to from this equation? A is equal to T over 2.5 minus the 9.8 that we would have here. So B will be equal to T over 4.5 minus 9.8 as well. So A plus B then, A plus B is equal to T over 2.5 plus T over 4.5 minus 2G or 19.6. It doesn't really matter, I'll leave it as G for a sec. So if we combine these two, I'm going to get 2.5T plus 4.5T on top over 2.5 by 4.5, which is 45 over 4, which is 11 and a quarter, 11.25 minus 2G. So I'm going to get 7T over 11.25 minus 2G is equal to A plus B. Does this help? I now have just an expression 6.3G minus 2T is equal to 3.15 times A plus B, which we have as 7T over 11.25 minus, I'll just change it to 19.6. We have to work out the answer here. So 61.74 minus 2T is equal to 3.15 by 7 is 22.05 T over 11.25. Doesn't work out evenly. And then 3.15 by 19.6 is 61.74 as well. So I'm going to get 123.48 if I bring this guy to the left, equals And that's giving me 1.96t when I simplify it, plus 2t. So 3.96t equals 123.48, giving me tension to be 31.18. Repeating. Does it ask for decimals? I can't remember what the question said. I think it was 2 decimals. So 31.18 for the tension in the string for part 2.